Hey guys, this is Jeremy J and welcome to Illustrated Maths.
Hi guys, welcome to the third video of functions, the basics of functions part 2. In this video, we'll be learning about domain, codomain, and range, and also the three ways of expressing them. We will also look at the symbols and alphabets that are usually written at the back of the function equation. And of course, we will apply what we have learned in a few exercises.
We are now in the third video of functions, the basics of functions part 2. Let's try to understand domain, codomain, and range. Domain are inputs that go into a function. I have my trusty onions and potatoes to demonstrate this. As you saw, potatoes and onions went into the machine, so my domains are potatoes and onions. Another word for an input is an object. Codomains are outputs that the function is capable of producing. This chopping machine model T1000 is capable of chopping any food that's the size of a pineapple or smaller and does not have a hard exterior like a coconut. Therefore, my codomains are any food that the machine is capable of producing, which are foods that are smaller than a pineapple and does not have a hard exterior. Range is what output the function can produce from the domain or input that the function got. Since only potatoes and onions went into the machine can only produce chopped potatoes and chopped onions. Another word for an output is an image. Now that we understand domain, codomain, and range, let's look at ways they can be expressed. Arrow diagrams are a visual and holistic way of expressing functions. We have the input which we will put into the oval shape here. The arrow is the function, and the oval shape on the right is the output. We know that the domain is potatoes and onions, so we put them into the oval shape on the left. The codomain is supposed to be foods that are smaller than a pineapple and have a soft exterior, but just to simplify things, let's say that the machine is only capable of processing potatoes, onions, kiwi fruit, and tomatoes. The kiwi fruit and the tomato is not in my range because I did not input them into the machine. So the arrow will connect the input to the result. The potato will become chopped potato and the onion will become chopped onions. Another way of expressing functions is to use a graph. The x-axis is the domain, which is food that went into the machine, and the y-axis is the codomain, which is all the chopped food that the machine is capable of producing. The potatoes and the onions will go to the x-axis. The chopped food that the machine can produce will go to my y-axis. And we will plot the range against the domain. Ordered pairs is the simplest way of expressing function. You don't need to sketch like arrow diagram or plot like graphs. You just need to put your domain and range into brackets. You start with one object and its image. Here we start with our potato and the image is the chopped potatoes. You keep doing this until you have written all the pairs. Since we only have two inputs, the second pair would be onions and chopped onions. Let's try a maths example. Find the domain and range of the following function. Fx equals to 5x minus 6. Okay, hold on. We seem to have something new here. We have a symbol that looks like an E, but is actually a Greek alphabet called epsilon. This symbol means element of. X is an element of n. N means natural numbers. So the inputs are all the elements of natural numbers. Let's look at a table here to further understand the symbols and alphabets. The symbol R means real numbers. Real numbers are numbers from negative infinity up to positive infinity. They include whole numbers, decimal points, and fractions. I will use a set diagram to illustrate where the symbols are in the realm of numbers. The symbol Z are integers. Integers are numbers from negative infinity right up to positive infinity. They do not include decimal point numbers, so therefore they are actually a subset of R. The symbol N, or sometimes written as W, means natural numbers. Natural numbers are integers from 0 up to positive infinity. Sometimes you see an N with an asterisk, that means 0 is not included also. Since N comprises only the positive portion of the integers, therefore N is a subset of Z. Q and P are rational and irrational numbers. They are made by dividing two integers. If you divide two integers and get a terminating decimal, then this is a rational number. Terminating decimals are decimal numbers with a finite number of digits. For example, if you divide 1 over 2, you get 0.5. And if you divide 1 over 8, you get 0.125. Both of these decimals have finite number of digits. If you divide two integers and get a non-terminating decimal, then this is an irrational number. Non-terminating decimals are decimal numbers with an infinite number of digits. For example, if you divide 1 over 3, you're going to get 0.3333. There's no end to it. And the most famous irrational number is pi. You get pi by dividing 22 over 7. Since Q and P are decimal points, they don't belong in the set of Z. So that's why you see the two circles outside of Z. But they are still real numbers, so they belong within R. Other symbols include I, imaginary numbers. Imaginary numbers are numbers that are not real. We have the symbol C, which means complex numbers, the combination of imaginary and real. We have the symbol E and O, which are even and odd numbers. Even and odd numbers belong in the Z set. Now let's solve the question. Now that we know our inputs are natural numbers, the domain starts from 0 right up to infinity. It would be absurd to list down all the objects of the domain, so we can just write the first 4 terms followed by 3 dots. We first substitute 0 and we get an answer -6. The next term is 1, which gives you -1. Substituting 2 gives you +4. And lastly, substituting 3 gives you 9. As you can see, the answers or images are ascending just like your domain. So the image is -6, -1, 4, 9, and so on. Let's try some more exercises on what we have learned so far. Express the following table in the form of arrow diagrams, ordered pairs, and graph. From the table, we can see there are 4 objects and 4 images of those objects. For arrow diagrams, the objects will be on the oval shape on the left, the images will be on the oval shape on the right, and the lines will connect the images to the objects that make them. For ordered pairs, we'll have 4 pairs of objects and images as seen here. For graphs, the object will be on the x-axis and the images will be on the y-axis. Let's try one last question. The arrow diagram on the left shows a function between set A and set B. Find the image for object 4, the object for image 5, the function notation, domain, and range. Before I proceed to answer this, I would like you to press the pause button and try to solve this question yourself first. Once you have finished, then you can click play again. Okay, let's see if you got them right. Image for object 4. Object 4 is connected to the image 2, so the answer is 2. Object for image 5. We look at which object is connected to the image 5. The answer is 7. For function notation, we have to figure out how the images are related to the objects. Looking at the three pairs, we notice that they have a difference of 2. Therefore, function of x equals to x minus 2. You may notice that I've written two different formats for the function notation. Both formats are allowed in function and they mean the same thing. Domain is all the objects in this function, so it is 4, 6, and 7. And range is all the images connected to the object, so the range is 2, 4, and 5.
Now that we have covered the basics of functions, I believe you guys are ready for the next stage, composite functions. But learning the basics alone is not enough. You guys have to practice. And always remember, in maths, there is no substitute for practice. I'll see you again next week. Bye.